So today's topic will be maths used in astronomy. So this is an easy level of what would be in astronomy, like what are the things that are used in astronomy, and one very basic thing is the notations, like 10 raised to the power of 2, etc. So these things would be very used in mathematics and astronomy also to calculate many things like what is the mass of the sun. It would be like 10 raised to the power of 30 kgs. So yes, this thing is very often in maths and astronomy, which is very basic
Yeah.
to
So
understand.
Aryan, first of all, you can give me your short introduction. So many of person is join now. Then other person is also join soon. So first of all, you have give the introduction, and Shreya is also joined, and Akashji, and one of the person is joined from the Jaipur location. So first of all,
Okay.
yes. Firstly, you give the short introduction your side. Then you can start. I will have to start.
Yes. So my name is Aryan Kumar and my father's name is Naveen Kumar. I'm 11 years old. So today I'm going to present something on upon what is the maths used in astronomy. It is what you can call a very simple level of maths that is used in this field, astronomy. So this astronomy relies heavily on mathematics to understand celestial phenomena, like the notations one, which are used to represent numbers. So maths helps in calculating distance, size, and movement of celestial bodies. So a solid grasp of basic maths concepts is essential for anyone interested in astronomy. So like, how will you represent something that has weight? You will always apply the kg, etc. So yes, there are two parts of one thing, and the first thing is the unit, and the second is the magnitude. And if I want to explain that, if I have 10 kgs, then the what would be the magnitude? The magnitude would be this 10, and the unit would be kgs. So this is very essential, which is very basic maths, which I think everybody here knows what are magnitudes and what are units. So units is here, the unit is kg and the magnitude is 10. So yeah, this will be a part of maths in what we call astronomy. So everyone, should we start?
Yes, Shreya.
Yes. Yeah. So okay. So now we are going to start, and as we know that basic arithmetics, which are addition, subtraction, multiplication, and division. So the simple arithmetic is often used to compute distance and sizes of stars and planets. Addition and subtraction help in determining the orbits of celestial objects, and multiplication and division are used to scale measurements to astronomical units. So if I want to explain that, if everybody here knows what is the mass of the sun, which is about 2 multiplied by 10 raised to the power of 30 kg, which is an implication of multiplication to uh, grasp the scale of measurement. So yeah, so everybody here knows. So I think we should move to the next topic. Unit. So understand light year and astronomical units in astronomy, converting
Your voice is
requires
not
basic
coming, Aryan.
understanding.
Your voice is buffering.
Understand.
Aryan voice not coming at all.
Okay, is it is now coming? Is it coming properly now?
Yes.
Okay. So converting between different units requires basic understanding of ratios and proportions. Familiarity with metric units helps in comprehending astronomical data. So as you can see in the picture given, the distance from the Earth and the Moon, light takes about 1.3 seconds to cross it, and in the last one you can see that the distance between the Earth and the Andromeda galaxy is about 2.5 million light years, which is about light takes about 2.5 million to go there.
Yes,
So
Aryan.
like,
Yes, Aryan, you have
yes,
raised your hand. Please, you have any question? Aryan?
okay, what's the question?
Yes, if a black hole died,
What's the
then slowly vapor, then evaporation completed, then what happened? That black.
so I think you are
Aryan,
you're asking.
your voice is not coming. What happened your side, Aryan? You are not in network?
No, I okay. So your question is what happens when a black hole is completely evaporated due to Hawking radiation?
Yes.
So okay, so this is not related to the topic, but I will answer this. So according to Hawking radiation theory, a black hole emits radiation due to quantum effects near the event horizon. As a black hole radiates, its mass decreases, eventually leading to complete evaporation. This process is known as black hole evaporation, but there are theories regarding it. When a black hole is completely evaporated, we do not know right now what happens, but we have theories like the information about matter consumed by the black hole will come and will come out of it. So this nobody really knows right now, but there are theories which suggest what would happen if a black hole is completely radiated. So some outcomes would be like gamma ray burst, uh, some possible remnants, etc. So yes, nobody really knows what could be. So is this answer satisfactory?
Yes, but why scientists do not try? Because black holes are so many, or universe is like singularity. Then black holes are too many. Why scientists cannot discover that?
So like a
Black
black
holes
hole
are
takes.
just satellites, or they not want to study on that.
Okay, so that is a good question, but I will say that these take about a Google years to just evaporate. That would be like 10 raised 100 zeros before one. That would be like one so many years that we cannot imagine it, cause this Hawking radiation is very small, and it would take thousands of trillions of years to completely evaporate. So yes, but if we could have tried, we will try that. But that is not possible because it would take one Google years, which is very large amount of time. So yeah, it is like 10 raised to the power of 100 years. So okay, what was this enough?
Yes, then I think in universe somewhere these things is happening, but our satellites cannot discovering that because that is too far. I think.
Okay, so I don't think so. I didn't understand what you said. Can you repeat?
I say, I think in the universe somewhere this thing happening complete. Evaporation was get completed and radiation. So our satellites cannot discover that because I think that was too far from our satellite range.
Okay, so I think that what you are saying is highly theoretical because that would, if that was the case, the everything that we have studied was wrong. Because if a black hole evaporated right now, it would put the questions on the Big Bang theory, etc., the age of the universe, etc. So I don't think so. That is right, but I think so in the far future that can happen. So I think we should move to our topic. So we were on the units of measurements. So like we can also measure speed, which is the speed of light. Everybody knows is how much energy. So most of the people do not know what is the what we call unit of energy, which is joules. So if an apple falls on a table, it can generate about 1 joule of energy, and force would be like the Newton force, and pressure would be like the Pascal, which I think so we will discuss in some far PPT, but right now we will not discuss that. Would be just too deep, and temperature would be like Celsius, Fahrenheit, and Kelvin. So in summertime, the temperature can reach about 50 degrees Celsius. So yeah, and everybody knows about the speed, which is meter per second, kilometer per hour, miles per hour, etc. So yes, these are some basic ones. And in astronomy, we will use the distance. In astronomy, the main thing is the distance, which is, as you can see, the distance from the sun to earth is about 8.3 minutes or 1 AU, which is astronomical unit. So light takes about 8.3 minutes to cover one astronomical unit, which is 150 million kilometers approximately. So light years, as you can see, to Alpha Centauri, it takes 4.4 light years. It is the distance when light travels in a straight line for 1 year. And parsec, which is about 30 point or 3 light years, and kiloparsecs are 1000 parsecs. So yes, we will discuss that in some further slides. So yes, and many things are used in astronomy, like to measure how much the mass is of the sun. We will use the notation or the what I have already told, the raised to the power of etc. So yes, and ladies and gentlemen, any questions for me? So okay, I I don't think so. There are any questions for me. So we are moving to the next topic. So geometry in astronomy. So geometry in astronomy is used to understand the shapes and sizes of celestial bodies. So this helps astronomers determine distance to nearby stars. The concept of angles is vital for mapping the sky and locating objects. So as you can see in the picture given, the this thing is used for mapping the sky and locating objects. So geometry in astronomy, it is what is it is used for. So that would be mapping or determining where the star is. So like it describes the celestial shape and orbits of that single object, and calculating distance, size, and positions of objects. As you can see in the picture given, the Earth's equator is there, the North Pole and the South Pole, the horizon, etc. So the word given triangulum, measuring distance to nearby stars using parallax method. So that is the parallax method is about in your hand. If you put your thumb and see the stars, but it is just what we call approximating what is the distance. So yes, and astronomical coordinate systems, as you can see, this thing can be used for mapping the coordinates also. So yes, some real world example would be like the Kepler mission of NASA, and the black hole imaging, the black hole that we had captured some time later was used by this concept to take that picture. Okay, Shreya, can you read this one? Hello, Shreya. I don't think so. Shreya is here. Aryan.
Yes.
So can you read this slide for everyone?
Yes. Geometry, geometry in astronomy. Geometry is used to understand the shapes and size celestial bodies. Triangulation helps astronomers determine distance to nearby stars. The concept of angle is vital of mapping the sky and location objects.
Okay, so that was fantastic. So as you can see in the picture, the horizon is there, which but this thing is also part of a concept. In the later slides, I will discuss that. So, ladies and gentlemen, any questions for me? Any questions for me? Okay, I don't think so. So, should we move to the next topic?
I have
Okay, what's the question?
that question is not related to this, but it might happen that if in front of black hole, a thing which is 50 trillion degrees Celsius, then what happened to the black hole for 1 second?
Mm, so, your question is, in front of a black hole, if there is an object with very high temperature, what would happen to the black hole? So, as you know that a black hole can take up anything, even light can't escape it. So, nothing will happen. But if it gets too close around the event horizon, the object would get what we can call um will get spaghettified and go inside the black hole. So nothing really would happen. So that would be like a normal thing falling into a black hole. So yeah.
If that object temperature light 10 raised power of 1 gigajoule, then
I don't think so that is practically possible, but it will but there is one more thing that if it is right positions and angles, what would happen that it can get into its what you can call accretion disk, or what you can call become the accretion disk of the black hole, and it would be just fall into the black hole. So yeah. nothing would really happen in this scenario. There are two things, that it would fall into the black hole or it will become a accretion disk. So is this enough?
Yes.
So okay, now move to
Now
the
move
next
to the
topic.
next topic.
Trigonometric
Trigonometric
basics in
basics in
astronomy.
astronomy.
So
So
trigonometry is essential for calculating distance and angles in the universe. The sine, cosine and tangent function helps in resolving distance in space. Astronomers use the parallax method, which relies on
relies on
trigonometric
trigonometric
principles.
principles.
So
So
now I will
now
tell
I
what is
will
the
tell what is the
parallax method.
parallax method.
So the
So
what is the
what is the
parallax
parallax
method?
method?
It
It
I will
I
explain
will
it like
explain it
that.
like that.
If
If
you
you
It is a
It is a
technique
technique
used in
used in
astronomy to
astronomy
measure
to
the
measure the
distance to
distance
nearby
to
stars.
nearby stars. It is the
It is based
it is
on the
based on the
principle of
principle of
triangulation,
triangulation,
which
which
also has
also has
something to do
something to
with
do with
geometry
geometry
also.
also.
How it
How
works
it
that
works that
observers
observers
nearby
nearby
stars
stars
from
from
opposite
opposite
sides
sides
of the
of
Earth's
the
orbit,
Earth's orbit.
so measure
So
the
measure
angle
the
between
angle
the
between the
star and
star
nearby
and nearby
background stars,
background stars.
calculate the
Calculate
shift
the
in the
shift in the
star's
star's
apparent
apparent push,
position,
position,
parallax, which is
parallax,
called
which
the
is called the
parallax.
parallax.
Use the
Use the
parallax angle
parallax
and the
angle and the
Earth's orbital
Earth's
radius to
orbital radius
calculate
to
the
calculate
distance. So I think that would be around,
the
that would be
that
just
would be
too
just too
advanced for
advanced
this
for this
thing,
thing,
which is for
which is for
beginners only.
beginners only.
I think so. Some person has joined with the name Ravi Maheshwari. Hello, Ravi Maheshwari, are you there? Can I know your name? I think
I
he
think
joined
he
from
joined from
Jaipur.
Jaipur.
Hello?
Hello?
Okay, I don't think so. He is willing to talk. So move to our topic. So like this thing, parallax method, which is very advanced for everyone here. It is very, what do you call, a very advanced level of maths, and moving to, and this was the parallax method. So like what, so trigonometry plays a vital role in astronomy, helping us to calculate distance, angles,
Angles,
positions of
positions of
celestial bodies,
celestial
like the
bodies like the
parallax
parallax
method that we
method that
talked
we
about.
talked about.
So there are
So there
many
are many
concepts of it,
concepts
like
of
the
it like the
spherical
spherical
trigonometry,
trigonometry,
right
right
triangles,
angles,
etc.
etc.
That are used for calculating distance, height, and angles. Angles measured in degrees, arc, seconds, or
Seconds or
radians.
radians.
So this
So
thing
this thing
I
I
would be
would be
advanced for
advanced for
now,
now,
and we
and
will
we
discuss
will
or
discuss
break
or
down
break
this
down this
in
in
some other
some other
presentation.
presentation.
So some
So some
applications would be like
applications
the
would be like the
triangulation,
triangulation,
which is
which is
just a method
just a method
measuring distance to nearby stars using parallax method. The orbital mechanics, calculating orbital
orbital
elements.
elements.
So
So
like
like
as you know,
as you know,
there is a fear of asteroid or comet colliding with Earth, so it is used for tracking and predicting objects and positions of everything like planets, stars, uh, asteroids,
asteroids,
etc.
etc.
So
So
everybody had
everybody
heard
had
the
heard
word
the word
binary system,
binary system,
which
which
is a
is
group
a
of
group
two
of two
stars
stars
orbiting
orbiting
each other.
each other.
So there
So
is
there
one
is
more
one
thing.
more thing.
The
The
binary system
binary
is a
system is a
system of two
system of
stars,
two
but there
stars,
is
but
one
there
more
is
thing,
one more thing,
the three
the
star
three-star
system.
system.
So that is a very old problem, three body problem, when three stars
Three stars
are of the
are of
same
the
mass
same mass
and are going to
and are going to
orbit
orbit
each other.
each other.
So that
So
would
that would
result in
result in
chaos,
chaos.
and there
And
is
there is
another branch
another
of it.
branch of it.
There is another
There is
branch of
another branch of
calculus
calculus
made to
made
solve
to
it.
solve it.
So yeah.
So yeah.
I would take some real world examples like measuring distance to nearby stars, using satellites, calculating orbital elements of exoplanets, determining asteroid orbits using angular measurements. So, like that, NASA monitors what we call these op- motions and orbits of the asteroids to know will it collide with Earth or not. So, yeah. So, did everybody understand this topic? So, I don't think so. So, ladies and gentlemen, any questions for me?
Aryan, Nikhil Bhaiya is also joined now.
Okay. So, okay, Nikhil Bhaiya. So, Nikhil Bhaiya, we are discussing what is the maths used in astronomy. So, we have gone through 5 topics, which are of the arithmetic, geometry, trigonometry, units of measurements. So, right now, we are discussing is about the trigonometric basics, what it is used for, the parallax method. But this thing is right now too advanced, and we will break down it in some other presentations or later. And everybody knows about what the arithmetic problems. Okay, so I think no, none. There is no question. So moving to the next topic. So Shreya, are you here, Shreya?
Yes.
So can you read this slide for everyone?
Sure. The celestial sphere is a model used to map stars and other celestial objects. Understanding the coordinates on the celestial sphere requires basic geometry. The concepts of right ascension and declination are derived from spherical geometry.
So in this is the concept that we have discussed earlier, which was of the geometry one, and the picture is also somewhat similar to the that we were discussing. So that would be like some key concepts would be like a 2D representation of the universe, etc. So components, stars, fixed points on the sphere, constellations. So this is what we call some advanced level of mathematics used, and it also uses the coordinate system, like the elliptical system based on Earth's orbit using longitudes and latitudes. So I think most of the people here know what are longitudes and latitudes. Imagine these are imaginary lines dividing the Earth into parts. Some important circles would be like the horizon that we had discussed, the meridian, uh, like the prime meridian we see on the Earth, the celestial equator, which is also shown on in the picture. So yeah, some tools to observe it would be like telescopes, star charts, binoculars, etc. So if you want to know about stars, etc., you can use some digital resources like Stellarium, which I also use to see some stars, etc. It is a very great digital resource to understand objects in space. So yeah, this. So as you can see in the picture, there are many things like the vernal equinox, the position of sun in the sky on the first day of spring. So it is also known as spring equinox. It marks the beginning of spring in the northern hemisphere and autumn in the southern hemisphere. So typically falls on March 19, 20 or 21 around 12 p.m. So this is the day where everything is equal. The night is also equal and the day is also equal of 12 hours each. So, so there are many equinoxes of this also. This is just one type of it. So there are some cultural and historical significances also, like the ancient culture celebrated fertility and renewal, that the days are equal and the nights are also equal. So, but I will say that this thing is not exactly 24 hours long. It can the the day is about 23 hours 56 minutes. But we what is it called? For the sake of convenience, we declared it 24 hour. So okay, now now as you can see in the picture, there are many things, sections. So this thing is also used in mapping objects in sky. So ladies and gentlemen, any questions for me? Aryan, do you have any questions? Hello, Aryan. Okay, I don't think so. Is there? So now we are moving to the next topic. So the importance of algebra in astronomy. So algebra is used to solve equations that describe celestial motions. It allows astronomers to calculate orbital paths and predict positions of planets. Understanding variables and constants is essential for interpreting astronomical data. So algebra plays a vital role in astronomy, enabling astronomers to model celestial mechanics, analyze data, make predictions like simulations and modeling. But we will discuss that later. And something can be like the linear algebra describes orbits, trajectories, and spatial relationships. So many things are also there, like calculus is also used. Some astronomical applications would be like orbital mechanics, calculate trajectories, velocities, and positions, stellar evolution, etc. So, some real world examples would be like the NASA's trajectory planning uses algebraic calculations for spacecraft navigation. So, this algebra was what we call developed by centuries like algebra, etc. And the importance of algebra is the predicting power of this thing, the data analysis, and the theoretical understanding. So yeah, and so did did everybody understand this topic? Shreya, did you understand this topic? I don't think so. Anyone is here. So, Aryan, do you have any questions regarding this topic? Um,
Hello, yes, Aryan.
so, do you have any talk? Did you understand this topic?
Yes. Yes.
So, any questions? Uh, Do you have any questions for me right now?
Yes.
Okay, what's the
But
question?
that is related to Earth and meteors.
Okay, so
In this century, when meteors are happening, going to happen.
I didn't get your question. I think you are. How do we know when a meteor shower is going to happen, right? Okay, so your question is how we know that
Know that
meteor
meteor
showers,
showers,
how
how
how we know that
how we know that
when is
when
that
is
is going to
that is
happen.
going to happen.
So we can
So we
predict
can
when a
predict when
meteor
a
shower
meteor
will
shower
occur.
will occur.
Astronomers track the orbits of comets and asteroids, which leave behind trails of debris, which is also a application for maps used in astronomy, like the algebra, etc.
Etc.
So yes,
So yes,
this is
this is
somewhat
somewhat
related to
related to
maps,
maths,
like
like
predicting
predicting
when a
when a
meteor shower.
meteor shower.
It is
It is
the
the
importance of
importance of
algebra that
algebra that
makes us
makes us
do these
do
things.
these things.
So,
So
was
I
this
was
enough?
enough.
Aryan, was this answer enough?
Answer enough?
Yes, but what if meteor shower was going to happen and the meteors are too big like moon? Then what happened?
So, like that, I don't think so that we can get into this, but I think so that there would be another extinction, but not that level, like the dino asteroid that killed all the dinosaurs. But I don't think so that it would be
It would be
practically
practically
possible.
possible
But in
but
theory,
in
we can
theory
say
we can
that
say that
if this
if
thing
this
happens,
thing happens,
what could
what could
happen?
happen?
Life could
Like
be can be restarted. So yeah.
so yeah.
Okay, so
Okay,
I
so
think so.
I think
Nikhil
so
Bhaiya
Nikhil
has
Bhaiya has
joined.
joined.
So
So
thank you for
thank you for
joining us.
joining
And
us.
if
And
you
if you
have any
have any
questions,
questions,
you can
you
raise
can
in
raise
hand
your hand
to speak.
to speak.
And I
And I
and I have
have
also
also
question
questions
related to ancient time.
Okay.
Some in my school or
or
EVS
yes
sir
sir
says if
says
we
if we
get a
get a
dinosaur
dinosaur
bones then
bones
we
then we
create a
create a
dinosaur.
dinosaur.
But recently few or later there is a
There is a
white
white
white rhino
white
was
rhino was
killed.
killed.
Then why
Then why
scientists do
scientists
not
do
make
not make
make that
make
rhino
rhino
again with
again with
their
their
DNA?
DNA?
So I think you do not understand this topic fully. We need two DNAs of a
I
male
am
and a female.
saying, or EVS sir says, if we
If we
get
get a
dinosaur bones,
dinosaur
then we create dinosaur. Then,
then
but
but
dinosaurs
dinosaurs
bones
bones
now
now
become to a
become to a
fossil.
fossil.
Then,
Then
recently, there is a rhino died. There is
there
one
is
rhino
one
left
rhino
from
left
that
from that
species.
species.
That rhino
That
is
rhino is
white in
white
color.
in color.
So why
So why
scientists do not
scientists do
make
not
that
make that
rhino
rhino
with their
with their
DNA?
DNA?
Okay, so there are two assumptions that I am making that we need two DNAs of the male and the female, or we do not have the technology of the geoengineering or genetic engineering. So yes, there we need two DNAs to make it, or we do not have these what can call the power to make one.
What?
So yeah,
So yeah,
was this enough?
was this enough?
Yes.
Yes.
Okay.
Yes.
So now
So
moving to the
now
next
moving to the
topic.
next topic.
It is
It
about
is
the
about the
it is about
it is
the
about the
role of
role of
calculus in
calculus in
astronomy.
astronomy.
Calculus helps
Calculus
in
helps in
understanding changes
understanding
in
changes
motion
in
and
motion
position
and
over
position
time.
over time.
It is used to
It is used to
calculate
calculate
orbits and the
orbits and the
gravitational effects
gravitational effects
of
of
bodies in
bodies
space.
in space.
Integral
Integral
calculus can be
calculus can
applied
be
to
applied
find
to find
areas under
areas under
curves
curves
representing
representing
celestial paths.
paths.
So
So
this
this
calculus plays a
calculus plays
crucial
a
role
crucial
in
role in
astronomy,
astronomy,
enabling
enabling
astronomers to
astronomers to
model
model
complex
complex
celestial
celestial
phenomena,
phenomena,
analyze
analyze
data,
data,
make
make
precise
precise
predictions,
predictions,
So many things are working together to predict many things what are going to happen, etc. Some key calculus concepts are differential calculus. It studies the rate of change, velocities, and accelerations. So yes, and there's one word, vector calculus analyzes gravitational fields, electromagnetic waves, and fluid dynamics. Some applications would be stellar evolution, models stellar life cycles, nuclear reactions, and energy production.
Aryan,
Orbital mechanics, yes, okay.
someone is asking Akashji, okay, what is astrobiology? So Akashji
Okay,
asking for you. You can see now after sender to you.
Okay. So what is astrobiology? So wait a minute. Okay. And I will say like this thing, astrobiology is the study of the origin, evolution, distribution, and future of life in the universe. Some questions would be related to that. Is how life originates on Earth. Is life unique to Earth? Is it very rare and can be found anywhere or not? Or is there any aliens there? So yeah, some research areas are also going on, like the Martian geology potential biosignatures. We are we are some there are some missions going on Mars to can figure out its geology. Does it have water, which it has, and it is so much that it can flood the Martian soil by 9 or 8 meters, which is very much. So it is just like trying to find life outside Earth. So yeah. so was this answer enough?
Akash, is this answer enough? Okay, so okay, I would give a summary of that. So astrobiology is the search of life.
This is question that how. Yes, sir. This is question that how. So his question is how life was originated. So I think this is the question that he's trying to ask, right? So one of the most fundamental and intriguing questions in astrobiology. There are many theories on life origin, like the primordial soup hypothesis. Life emerged from a mixture of organic compounds in early Earth ocean. That would be like we we are made up of stardust or star material. In the beginning of the universe, the hydrogen was emitted, and that made stars, etc., which made even heavier particles, which made oxygen, carbon, etc. And that thing made the cell, and the that thing helped life to evolve. So yeah, now moving to our topic. So where were we? I think so. We were.
Aryan, I have one question.
What's the question?
Akashji,
Yes, that what is meaning of electromagnetic wave?
So regarding electromagnetic waves, so these are energy waves that propagate through the electromagnetic field. So that would be like waves carrying energy, or these can be also called the energy waves that
Are moving throughout the universe. So every electromagnetic wave travels at the speed of light.
Like it range from low frequency to long frequency, etc., etc. So yeah, many things are there like radio waves which have long wavelength, like the redshift and blue shift. So is this answer?
Yes, then what do you mean by gamma rays?
Gamma rays are just one of the types of the electromagnetic waves which are what you can call short, very short wavelength and have very high frequency. They are short wavelengths, and in science, if it is small, if the wavelength is small, there would be more energy. So yes, yes.
आवाज मेरा आउच तुम्हें तुम्हारे बन जाएगा तुमने तुम्हारे लिए खुद से की
Yes,
Okay, so
आर्यन, आकाश जी, आप सेटिस्फाइड है ना आंसर से? सो यू
यस
हैव
Okay, so we are going to move to the next topic.
So, Akash,
Data analysis.
you have any question, please, you have to speak with Aryan. Don't worry, don't hesitate anything. Aryan is only 11 years old. He is studying in 6th grade. He's only explore more and more all things. So, you have to try to speak with Aryan.
Okay, so don't be hesitant to speak. I'm in grade six, and I'm trying to learn and more. So yeah, now moving to the next topic, which is about data analysis in astronomy. So it can be. So what is data analysis in astronomy? So astronomy generates vast amounts of data that requires statistical analysis. Basic statistics help in interpreting data distributions and trends. Understanding averages, medians, standards, divisions is important for a data analysis.
so I think this needs to be explained. Like if I take three numbers, 10, 10, and 10, what would be their average? So average, we are going to add these all up, which equals to 30, and divide by how many numbers there were. Like there were three numbers, and we will divide that by 3, which equals to 10. So the average number of these would be 10.
So yeah, okay. So okay, so and another fantastic question from Akash. So, what is the Hubble's law? So, okay, I will answer that, but first let me explain the slide.
So there are many things, there are many topics that are included in this, like it is all the math summary output in data analysis. So yes,
And and moving to Akash question, what is the Hubble's law? So, Hubble law equation is about V equals H multiplied by D.
so how, so that would be like v equals to velocity kilometers per second, and h is the Hubble constant, and kilometer per second or mpc or megaparsec. So and the d equals to megaparsec. So yes, everybody knows that the universe.
So, everybody knows that the universe is about 13.8 billion years old. So, like this V multiplied by yes, I think I
Yeah,
have
yeah,
something.
you can continue.
Okay. So v equals to h multiplied by d. So this is the Hubble's law, and this Hubble's constant, which is the original value, is about 500 kilometers per second,
per megaparsec. So the current estimate is about 67 kilometers per second or megaparsec. So yes, there is 1% or 2% uncertainty. So yes, that would be like everybody knows that what is the universe is, and we can only explore that much. So yes, okay. So like everybody knows that it is 13.8 billion, and using the Hubble's law, this law will make it about 96 billion light years. So that is way too much of the what you can call uh, light years. So yes, this is the Hubble's law. Okay, so okay, another question from him. What is the value of the Hubble constant? So that would be like I think so. It is about average value is about uh, 70. I think so. It is about 70, around 70. I think so.
Um, I think so. I will discuss that later, cause it is a very vast topic. So it is about 70 kilometers per second per megaparsec, and so yes. Now moving to the next topic. So graphing and visualization. Graphing is crucial for visualizing astronomical data, and scatter plots and histograms help illustrate relationships between variables. Visual representation aid in understanding complex astronomical concepts. So this is what we can call just it uses many things like geometry etc. to make this thing. So yeah. Now moving. So this thing now we are going. What is the Doppler effect? So the Doppler effect is a key principle for measuring the speed of celestial objects. It involves understanding wave frequencies and how they change with motion. Basic algebra helps in calculating redshift and blue shift in astronomical observations. So this thing, Doppler effect is a fundamental concept of physics describing motion wave frequencies.
Yeah,
So like if
Aryan, your voice is not coming proper. Try to speak in proper.
okay, so like everybody knows if somebody is talking and they are moving away from you, you would not hear them. Okay, so I think the question by Akash, sir, can I become an astrophysicist by joining IIT? Yes, joining an Indian institute can be great step toward becoming an astrophysicist. So yeah, there are many things available like IIT Delhi's etc. So yes, you can. So moving to the topic. So there are two things, the red shift and the blue shift. As you can see in the picture, the person experiencing the red shift is experiencing lower frequency, and the blue shift person is experiencing higher frequency. So yeah, basic algebra helps in calculating the redshift and blue shift in astronomical observations. So now we have, I think, done with the math part, and now we are going to its implications. So yes, this thing helps understand calculating redshift, blue shift in astronomical observations. Okay, so now we are going to move to the next topic. Kepler, I think so. Okay, I think so. There is one more question. How will you become an astrophysicist? So there are many steps of it, like the education, taking the education for 15 years around it. Yes, these things. But my plans are of the RMC, Sanic School, and the UVICA. The UVICA exam is of ISRO's exam, which I think around 8th or ninth class. I will take that, and if that is cracked, I will become a astrophysicist in ISRO. And if does not, there are two more chances of the Sanic School and the RMC, where I can join the DRDO, which is linked to ISRO. So yeah. Now moving to our topic. So Kepler laws of planetary motion. Kepler laws describe the motion of planets around the sun using mathematical formulas. These laws involve ratios, powers, and proportional relationships. Understanding these laws require basic algebra and geometric concepts. So, okay, I will explain some laws of this. Sir, is there? Okay, another question for me.
Are you,
So,
are you,
yes.
yes, why Chandrayaan 2 fail?
I think there was some problem in the lander, and the mission was 96% successful. So yes, I think so some uh, problem was in the lander. So yes, moving to the other question, sir, is that law has the equation P equals yes. Okay, so you are referring to the Kepler's third law, which I was going to explain. So first law is of the elliptical orbit. Planets orbit the sun in an elliptical path with the sun at one focus. The lines connecting the planets to the sun sweeps equal areas in time. And the last law, where the equation that you had mentioned, the planetary orbital periods are proportional to the semi-major axis A, which I think so you have already what you can call given the equation. So, so yes, I also in touch with some ISRO scientists. I have some talks. I had some talks with them also, and asked about the next topic, next launch, which was about the Gaganyaan. I think so. So yeah. Now we are going to the next topic.
Hello, Aryan.
Yes.
Uh, yes, can you take topic on next Sunday related to Newton star and supergiants?
I didn't get your voice was buffering. Can you say it again?
On next Sunday, do you take a topic on Newton star and supergiants?
Okay, okay, I will try to make that thing. So yes, now we are going to the Hubble's law. So yes, I think so. Aksh had the question, and I had already explained this. So the farther the galaxy, the faster its motions away from us. So more commonly known as the Heron's formula, it is especially associated with astronomy or planetary motion. Oh, sorry, I was doing the wrong. So the Hubble's law, the further the galaxy, the faster its motion away from us. So the slope is equal to the Hubble's constant. So the it is what we call the reflection between the velocity of galaxies and the distance from Earth. So yeah, I have already explained this. So because of us, we had already discussed this, and the Hubble problem relates the distance of galaxies to their velocities. It involves understanding linear relationships and slope calculations. This concept is fundamental for studying the expansion of the universe. So now moving to the light and optics. So Matt, so Aryan, hello Aryan, hello Aryan.
maybe वो left हो गया है आर्यन. Actually network issues आ रहा है some location से. So you can continue. And uh, if anyone want to speak with Aryan, please speak. Akash ji also, you can also speak with Aryan na. So you have any questions and you want to add something in presentation and all things. Okay, Aryan, you can continue.
Okay, okay. So we are now heading to the light and optics. So some key concepts I will explain, but let me read the slide first. So math is essentially understanding how telescopes and other instruments work. The relationship between light, distance, and angle is governed by geometric principles. Calculating focal length and magnification involves algebra and geometry. And some key concepts would be like reflection, refraction, diffraction, etc. Um, some laws of reflection: incident angle, reflected angle, the incident plane, the reflected plane. So there are many laws of it also. There are many types of lenses, convex lens, etc. So like if I have a telescope of about 900 or 600 mm, and I have a lens of 10 mm, so I will get a magnification power of 60. So yeah. Okay, so ladies and gentlemen, any questions for me? Hello? Okay, I don't think so. Anybody has some questions? So please just wait a minute. I think I am having some issues. So can you hear me?
Yes, yes, you can continue.
Okay, so there was some problem. So yeah, we were topic understanding gravity. So gravity plays a crucial role in the motion of celestial bodies. Mathematical equations such as the Newton laws of gravitation describe gravitational forces. Understanding these equations is fundamental for studying orbits and celestial interactions. So yeah, so it's already time and the presentation. So as you can see, these two are pulling on each other. So the pull of gravity that changes the path of the moon, but in reality it is just wobbly. The cosmological constants. It is involves advanced math, reflects the expansion of the universe, and requires understanding of calculus. Basic familiarity is with mathematical constants and their implication is simulation and modeling, and I think so we have already
Yeah, Aryan, your voice is waffling. Your voice is always waffling. Can you speak once again?
So we have already discussed this topic in around the five slides, and math is used to create simulations of astronomical events and phenomena. Understanding algorithms and computational methods is essential for modeling. These simulations help predict outcomes and visualize complex astronomical systems. Light year and distance calculation. So light is the distance light travels in 1 year, requiring units and position. Calculating distance using light involves understanding speed and time. This concept is fundamental for measuring vast distances in space. So yeah, light year measurements. So the distance from the Earth to the edge of the observable universe is about 14.26 gigaparsecs, or about 46.5 billion light years. So in any direction, the observable universe is such a sphere with a diameter about 28.5 gigaparsecs. So yeah, the future of astronomy and math. So we are doing some projects that would help us to understand how astronomy and math would work. Like we have launched the James Webb Telescope, which had uh, given us some stunning images of the past. So now we are heading to our questions. So a parsec is about we can call 30 kilometers. Kilometer is how much distance travels in a year. So data analysis helps us to understand how or predicting of what is going to be the next one. So simulations and modeling helps us to understand what is going to be happening or what would happen in the typical scenario. So there are about 46 gigaparsecs in the universe. The Hubble's law is the farther the galaxy is away from us, the farther it will move away. So light and optics helps us to understand the importance of light and its properties. So the Doppler effect is about redshifts and blue shifts. Of motion are about the motion of the planets move. So now we are done with the
Your voice is
annual.
not coming, Aryan. What happened your side?
Okay. Thank you. So presentation, and if you have any further questions, you can ask me right now.
So I hope everyone liked it. So
So
Robert
yeah,
is just joined,
I
Aryan.
think
Robert is just joined.
okay.
Aryan, on your video and speak with everyone,
so
and also some.
So you have really noticed now we are going to end our meeting. So I will summarize what we have learned. We have learned about what is the basic math that is used in astronomy. We have discussed about trigonometry, etc., about the light distance and conversions, the units of measurements, trigonometry basics, the role of calculus, and the importance of algebra. The Doppler effect, the Kepler laws of planetary motion, and the Hubble's law, which we explained in brief, and understanding gravity. So this was the main topics in our presentation. So yeah, any further questions for me? So I don't think so. So should we end the
Yes, Aryan, Nikhil Bhaiya, you have some add some point from your side, and you can advise anything for Aryan.
Yeah, actually, there is a power cut here, so there is a network issue for me. Am I audible clearly?
Yes, sir,
Hello?
you are audible, sir. Yes,
Okay. Yeah, actually, I have heard the presentation, but I have joined in the middle. So, from the trigonometry onwards, I have heard everything. It was good actually. The concept was good actually. The concept you have taken, and the explanation was also really fine.
right.
Yeah.
And some new person is also join like हरि शंकर जी. आप बताएंगे कहाँ से हैं हरि शंकर जी? थोड़ा आप अपने बारे में बताएंगे? You have joined the first time. And other is आकाश. आकाश जी आप थोड़ा बताएंगे आप कहाँ से ज्वाइन किए हैं? And some person is Robert. Robert from.
Yeah, Robert. He's also from Cosmic Bus.
अच्छा.
Yeah, he's a new person from Cosmic Bus. Hi, Robert.
Yes, yes, yes. आकाश जी दिल्ली से हैं. Good. And Robert from Algeria.
Yeah, he's a part of Cosmic Bus now.
Yes, yes, yes.
He has
Right.
collaborated with us.
Okay, great news, sir. And Aryan is also asking me, कि, Papa, you have entered the wrong number. And I have received the message from the cosmic box. I'm really don't worry about that. You have got the, some gift.
Yeah.
So,
He also got the prize for Cosmic Bus. Soon we will dispatch those prizes as well to the people. Actually, we are busy as this is a wedding season, na? So we are
Yes,
busy
yes.
with some
Festival.
things.
Yes, yes.
Yeah. So we'll be dispatching those gifts by next week.
Oh, no, not in issue.
okay.
Just.
Yeah.
एंड आकाश जी आप कुछ बताइए प्लीज आप अपने बारे में. डोंट हेजिटेट. एंड आप किस क्लास में हैं? आर्यन. आर्यन आप थोड़ा सा ब्रीफ दे दीजिए हल्का सा एक बार और वंस अगेन.
Uh, I didn't get you. Can you repeat? Your voice was buffering.
अच्छा. आकाश G7 में है. अच्छा गुड. आर्यन इज 6. आर्यन. यस मे भी हाँ मे भी आपसे डिस्कस हुआ है आपको लास्ट टाइम.
Uh, I think we had already discussed about him. So yeah. Okay. So
So
Akash, do you have any further questions? So I don't think so.
ओके एंड ओके मीटिंग को एंड करते हैं. इट इज टेक 1 hour also. And Aryan, what is the next topic?
So about for join.
अच्छा सुपर सर.
Aryan suggested me that I should make a presentation about it. Yeah.
Okay. So you have any question for about the astronomy to Robert ji and Nikhil bhaiya? So you can talk with them and after that in the meeting.
Yeah. As far I don't have any doubts on this. What about you,
I
Robert?
don't think.
You have any doubts on this?
No, no, I haven't.
Cool, then.
Okay. थैंक यू सो मच फॉर एवरीवन. एंड बहुत अच्छा लगा कम से कम आप लोग ज्वाइन कर रहे हैं. बच्चे ज्वाइन कर रहे हैं क्लास में. स्टडी कर रहे हैं थोड़ा मोड़ा. ओके तो आर्यन यू कैन समराइज एंड इन द मीटिंग.
Okay, so yeah, in this presentation, we had discussed about the basic maths used in astronomy. We didn't go in depth because it It was for beginners, so we discussed about the use of measurements, the use of geometry, trigonometry, etc., the role of calculus and the importance of algebra. So yes, many things we have discussed in this presentation about the Hubble's law, the light years, measurements. So yes, so this was the summary. So yeah,
Okay, Aryan.
okay,
Okay, thank you so much for join and you have present all things in brief way. We
okay,
will meet and next Sunday for new topic.
Yeah, sure.
Okay.
Thank you so
Thank,
much.
Thank you, Aryan. Thank you.
thanks for joining.